Hey, welcome back to Well, That's Interesting, the Get Your Mind Out of the Gutter and Into the Cosmos edition. Today is episode 275. We need to talk about this five-way galaxy merger and Cloud 9, a new kind of celestial object. My friends, if you're a long-time listener of this show, or if you're a fledgling business goose who has just joined us in the last few weeks, that's still enough time to notice the latest trend in the latest space news we've been covering. Recent discoveries have been unpredictable and downright wild. Just last month, during episode 272, let's talk about the prince who was mauled to death 27,000 years ago, and super kilonovas are a thing, and one may have popped off twice. Once we put our jaws back in place after hearing about one young man's fate, we then fainted at an event called a super kilonova. And not to give everything away here if you haven't had a listen, but thanks to the stubbornness of researchers at Caltech's Polymer Observatory, what was thought to be a common supernova by most of the astronomical community might very well be a super kilonova after quite a thorough analysis. In short, a super kilonova is a proposed, highly energetic, sexy two-stage cosmic explosion where a massive star first explodes as a supernova, leaving behind not one but two dense stellar remnants called neutron stars that immediately orbit one another and then collide to produce a kilonova. Now, if none of that made sense to you, girl, you need to hit play on episode 272 after this episode. Then, back in February, during episode 269, JWST discovered an exoplanet so strange, even researchers were speechless. And that's even the title of the show. There is so much happening with that so-called exoplanet, researchers threw up their hands and labeled it an exoplanet because only two of its multitude of characteristics make sense. Its low mass and it's orbiting a star. As of today, there's no proper category for whatever the hell it is. Today is just as action-packed and confusing, but the kind of confusion that leaves you amazed. In the first half of the show, although Texas A&M University is eliminating its women's and gender studies bachelor degrees and graduate certificates, there is colossal work still being done by their physics and astronomy departments, who at this moment are still operational. As reported by Leslie Henton of Texas A&M, astronomers have discovered a rare, tightly packed collision of galaxies in the early universe. And, okay, I get it. At face value, that statement may sound benign, as galaxy collisions are a common thing. But baby girl, when we get into just how soon after the Big Bang these galaxies formed and Big Banged themselves together, we will once again faint at the power of this universe of ours. We will meet the team that got their hands on JWST, and we will learn what they did with it to collectively shred the widely held belief that complex galaxy mergers, and with it the dispersal of sweet, sweet oxygen and other products of stellar fusion, could only happen over 1 billion years after the Big Bang. That means we will learn how much earlier than that this five-way occurred, who the galaxies were involved, and what was inside them. And spoiler, a lot, which is throwing another expectation out the window, one that galaxies at the time were relatively small, isolated with a sprinkling of massive stars. We are finally seeing what actually happened then to eventually form the universe we know today. And you need to see it to believe it. So fire up today's post on the old socials now. Then after the break, what may be considered the first confirmed failed galaxy. Now, on face value, that statement sounds really fucking mean. But as we soon shall learn, thanks to this empty puff located 14 million light years away, we now have a better understanding of the critical mass threshold needed for a body of gas and dark matter to collapse into a functioning galaxy. And no biggie, this mostly empty puff has also helped to prove a cornerstone of the leading cosmological framework that aims to explain the structure and composition of the universe, the lambda cold dark matter model. That's hard to say, and it will be explained. And it will all go to show that failure is just how you look at things. We will get into what few characteristics Cloud 9 has, why that's so important, and the answers it's providing. and we will learn about the brand new category it falls into, relic, or reionization-limited hydrogen gas cloud. Also difficult to say. In the meantime, hi, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my bountiful business goose. To begin, you and I are about to cozy up and get down to the groovy sounds of Stephen's Quintet. A group whose name makes you think we've just settled into the velvety cushions of a smoky jazz club, but not quite. We're actually looking over the shoulder of Édouard Stéphan, a French astronomer, who in 1877 became the first human to set eyes on the cold train of cosmic events. Using what could be considered, by today's technological standards, a crude telescope, he discovered 5 brightly packed lights in the constellation Pegasus. But these were too large and positioned far too close to be regular stars. After over a century of clickety-clack calculations, these lights have come into dramatic focus, revealing one hell of a tune. Some 210 to 340 million light-years from Earth, 4 galaxies are on a doomed collision course, with one galaxy dubbed NGC 7320, approximately 39 million light-years from us, who will arrive fashionably late to that party. And would you want to see this slow train wreck? Of course you do. So please, drop whatever crude thing you're holding right now and pick up your phone. Head on over to today's post on the old socials and you'll see JWST's capture of Stephen's Quintet, taken in 2022. I'll give you a second. Yeah, it is truly stunning. The words heavenly light get thrown around a lot, but seriously, the glow emitted by these 5 is the perfect visual representation of it. The softness coming from this image is so sleepy and comfortable, you forget that this is an apocalyptic situation. So needless to say, the beauty, danger, and the unique circumstance of not 2 or 3, but at least 4 whole galaxies about to merge makes astronomers salivate. This group is the most studied of all compact galaxy groups. And although we've been peeping on it for well over a century, Stephen's Quintet keeps pumping out the hits. Literally. 3 years ago, this group had its deepest probing ever performed by the 500-meter Aperture Spherical Telescope in China, and it found a 2 million light-year wide stream of hydrogen gas trailing out of one of the galaxies. I mean, we've all been there, but one must ask, how did this galaxy end up with a very long tail out of its butt? Well, it turns out it formed in the most violent way possible. Roughly 1.5 billion years ago, it's believed a sixth galaxy bowling balled its way through the middle of our quintet. And as reported by Ben Turner of Live Science, these researchers have identified a possible culprit. Galaxy NGC 7320A is currently hurling through the cosmos at almost 15 million miles per hour, and if we follow its steps backwards, they lead straight to the scene of the crime. If there was an award for best or most exciting cosmic group, this quintet would certainly win that Grammy year after year. But, and big but here, like with all pop sensations, just wait a little and there's a new one right behind. Though when I say new, I don't mean that literally. The group we're about to cover has been around basically as long as time itself. So it looks like we're fashionably late to this party. And what we're witnessing is upending so many basic beliefs about the early universe, this group makes Stephen's Quintet look like a boring honky-tonk. Sorry, Stephen. Let's get into it. So please, join me, will you, with Dr. Wada Hugh, a postdoctoral researcher and lead author of the study we're cramming right the fuck into now, and Dr. Casey Papovich, professor of physics and astronomy, both of Texas A&M University. Back in 2025, the pair got their hands on the James Webb Space Telescope, which means they were able to wield its 21-foot diameter mirror and infrared instruments. Together, by gobbling up infrared wavelengths, the JWST is able to see through much of the cosmic dust that obscures visible light. To be honest, it's the closest thing to having godlike vision so far. And with that vision comes remarkable insight. And shit that'll break your mind. Please refer back to today's post on the socials and swipe past the image of yesterday's news, Stephen's Quintet. The next image you'll see is a small black square, and inside that small black square is a chaotic number of lights. Each light is a galaxy, And although I described it as chaotic, there's actually organization here. This is about 17 galaxy clumps detected by the team. But there's one clump deep within this image that's changing the astronomy game. In January of 2026, in a press release, the team announced a new quintet, a new pop sensation called JWST's Quintet. And you need to sit the fuck down when you hear what it's putting out. As you can tell by the name, this group is made up of 5 galaxies. And the first wild thing about them is just how horrendously close they're positioned. 2 of the 5 appear to be separated by a distance of only 43,300 light-years. And the most distant pair among the galaxies in that system appears to be 60,700 light-years apart. So to put this wee amount of space into perspective, the entire Milky Way galaxy is 100,000 light-years across. You can put all 5 of these galaxies inside ours. This means, you guessed it, fun fact number 2, they, like Stephen's quintet, will certainly merge. And this lack of elbow room is already showing signs of intergalactic stress and destruction, leading us to fun fact number 3. JWST's near-infrared camera hinted at a large halo of gas around and outside the group of galaxies, specifically a halo of oxygen and hydrogen. So my friends, in terms of space, oxygen is only produced inside stars. So to find massive quantities outside several galaxies suggests gravitational interactions so intense that stars are being pulled apart or maybe even colliding with one another, and their innards are being flung into the great expanse. And the amount of debris we're seeing seems to make sense, as this all leads to fun fact number 4. As reported by Leslie Henton of the university's Division of Marketing and Communications, although the galaxies are separated by mere tens of thousands of light-years and occupy an unusually compact region of space, they each formed stars at a rate of about 250 times the mass of the sun per year. That is an overachieving amount of content to produce, and this is all extremely impressive, I have to say. But I'm saving the best for last. Fun fact number 5. JWST's quintet has a redshift of 6.71. Now, what the fuck does that mean? Well, it is a very dry way of saying something very sexy. Long, unfathomably long story short. Redshift is a measure of cosmic distance, which means the higher the redshift, the more distant and ancient the object is that you're measuring. Redshift occurs as the light emitted by that distant object stretches into longer, redder wavelengths while crossing our ever-expanding universe. JWST's infrared doohickeys can, air quotes, see this kind of stretched light. And 6.71, that reading basically means these galaxies, their star formation, the galaxy merger, all of this dramatic action took place a scant 800 million years after the Big Bang. And this fact has astronomers clutching their pearls with excitement. Quote, "What makes this remarkable is that a merger involving such a large number of galaxies was not expected so early in the universe's history, when galaxy mergers were thought to be simpler and usually involve only 1, 2, or 3 galaxies." End quote, Hughes said to Leslie Henton for the team's press release. My overwhelming business goose, not only was it thought that galaxies were too few and far between to merge at the time, the rate of star production by these galaxies, that of 250 solar masses per year, is far higher than anyone thought could be possible as well. With this discovery, we now know complex galaxy mergers were totally a possibility, and that widespread enrichment by life-giving molecules like oxygen and other products of stellar fusion were spreading around within 1 billion years, not after, as previously believed. And this discovery may help explain what we're witnessing in the more recent universe. In the same press release, Dr. Casey Papovich was like, "Y'all, our findings bridge a huge gap. JWST has identified a growing number of massive galaxies that appear largely inactive, just a few billion years after the Big Bang, meaning star production had slowed or completely stopped. If systems like JWST's quintet merged rapidly and exhausted their gas early, they could have evolved into these massive, quiet galaxies seen at later times. In sum, this may explain why so many galaxies are no longer active. As for what this quintet morphed into, well, we will not live long enough to receive and decipher that information, but the team did do some clickety-clack calculations and came up with a few theories. It's possible that these 5 galaxies and those 17 galaxy clumps could have eventually smushed into a single massive galaxy with a total stellar mass of 10 billion suns. And this may have happened approximately 1 to 1.5 billion years after the Big Bang, upon which its production of new stars would slow to a stop. And those already in existence would burn brightly for billions of years more, until every last drop of fuel was extinguished. But don't shed a tear. A star's lifespan, or the time it takes to burn out and exhaust its nuclear fuel, ranges from a few million years for massive stars to over 1 trillion years for small, low-mass stars. Massive stars die quickly, while stars like our sun live for about 10 billion years. So it's possible some of the quintet stars are still shining. In the meantime, JWST and mighty nerds are continuing to probe away, revealing more about the early universe. So, watch this space, no pun intended. You'll never know what new sensation will grace our stage. After the break, we are leaving this astonishing celestial event for a floofy ball of gas, closer to home. But don't let that description mislead you. Although mostly a void, it may help us solve one of the greatest mysteries of all. What in the holy hell is dark matter exactly? Something brand spanking new is next. Stay tuned.
This episode is brought to you by Indeed. Stop waiting around for the perfect candidate. Instead, use Indeed sponsored jobs to find the right people with the right skills fast. It's a simple way to make sure your listing is the first candidates see. According to Indeed data, sponsored jobs have 4 times more applicants than non-sponsored jobs. So go build your dream team today with Indeed. Get a $75 sponsored job credit at Indeed.com/podcast. Terms and conditions apply.
This episode is brought to you by MGM Plus. From and its Horrors returns for Season 4, centered around a town that traps all those who enter. Terrifying creatures that come out at night. Horrors some wished had stayed buried, where desperate hope leads to darker truths. Dangerous new arrivals, a sinister figure, a shocking revelation. From Season 4 premieres April 19th on MGM Plus. Some doors should remain closed.
And we're back. We are so back. And my friends, do you remember the 500-meter aperture spherical telescope in China from earlier in the episode? About 3 years ago, researchers here performed the deepest probing ever of our beloved Stevens Quintet, and they found a 2 million light-year wide stream of hydrogen gas trailing out from one of the galaxies. Yes, how could we forget? Well, let's just say those folks were on a roll. On their downtime, in between all the probings, they actually made an additional discovery. More than 14 million light-years from Earth, near the spiral galaxy Messier 94, the telescope identified several more collections of hydrogen gas. Upon first inspection, the majority of the blobs resembled the shape of, well, blobs. Shapeless bodies we've seen all around our own Milky Way galaxy called hydrogen clouds. But the 9th cloud under analysis? This one had definition. It was smaller, a wee 4,900 light-years across. It was more compact, highly spherical, and as far as they could tell, potentially starless. Whatever this is, it fell somewhere between a dwarf galaxy or a low-luminosity galaxy containing only a few 100 million to a few billion stars, and a hydrogen cloud. But with such scattered clues, the team serendipitously dubbed this cloud Cloud 9, until additional colleagues and hot-for-blob nerds could perform their own pokes and prods. First up were 2 other facilities who have appeared on the show many a time before, the Green Bank Telescope in West Virginia and the Very Large Array in New Mexico. If you're a longtime listener of this show, it should come as no surprise these big guns were up for the task of figuring out what the hell this cute ball of gas could be exactly. The Green Bank Telescope in West Virginia is the world's largest fully steerable radio telescope, standing over 485 feet tall and weighing 17 million pounds. It's located within the National Radio Quiet Zone, where zero human activities interfere with its 24/7 operations to detect faint radio signals from space. The aptly named Very Large Array in New Mexico is not one, but 27 radio antennas in a Y-shaped configuration on the plains of San Agustin. According to the National Radio Astronomy Observatory website, the data from these antennas, combined, give the resolution of a single antenna 22 miles across. Jesus. Right now, here, together, they combined forces, centralizing on the core of Cloud 9, ready to receive any and all radio waves. So, after severely eyeing the belly of this floof, what did they find? Drumroll, please. Yeah, not much. After measuring the amount of hydrogen gas in Cloud 9 by the radio waves it was emitting, all they could say is that this thing is approximately 1 million times the mass of the Sun. For galaxies in space, even dwarf galaxies, that is tiny. Their readings were so faint, they threw up their hands and said, okay, look, listen, I know we're kind of a big deal here on Earth, but that could be the problem. Whatever this is, and whatever it's composed of, it's barely emitting radio waves, so maybe try a telescope in space that has different instruments? My friends, which classic hero would you turn to in a case like this? If you said, girl, is Hubble available? You are not alone. In 2025, Andrew Fox of the Association of Universities for Research in Astronomy and the Space Telescope Science Institute for the European Space Agency, Alejandro Benitez Lambe of the Milano Bicocca University in Milan, Gagandeep Anand and Rachel Beaton of the Space Telescope Science Institute, and a collection of other human heroes got their hands on Hubble and its advanced camera for surveys, and holy shit. Turns out, Cloud 9 may help us solve some of the biggest mysteries in the universe. Let's get into it. And to do that, we need to talk about what it isn't. Quote, "It's basically a galaxy that wasn't," said Rachel Beaton at a meeting of the American Astronomical Society in Phoenix in February of this year. Rachel's statement is a simple one, but one that is sending absolute shockwaves through the astronomical world. Cloud 9 is beyond anything we've seen before. It belongs to a rare phenomenon, one that astronomers have been seeking for years, but up until right now has only been theoretical. This is the first ever confirmed reionization-limited hydrogen gas cloud, where the words hydrogen gas are represented by the symbol HI, so the acronym is pronounced relic. And what a fucking relic it is. This poof of neutral hydrogen is a leftover from the beginning of our cosmos, when horrendously large clouds of hydrogen gathered and collapsed under their own mass, condensing into stars, which eventually led to the formation of solar systems and stable galaxies. Cloud 9 falls just short of having enough mass to collapse into a galaxy, and this failure, if you want to call it that, confirms a cornerstone of the leading cosmological framework that aims to explain the structure and composition of the universe, the Lambda Cold-Dark Model. The Lambda Cold-Dark Matter Model. Now, what the hell is that? I am so glad you asked. Long calculation short. This model is the standard recipe for the universe, explaining its entire evolution from the Big Bang to what it looks like today. And today is a universe composed of roughly 5% normal matter, aka the shit we can see with our eyes and instruments, but more importantly, 27% slow-moving, cold, dark matter that holds galaxies together, and 68% lambda, or dark energy, which accelerates the expansion of space. Yeah, you heard me. You heard those numbers. Let's talk about cold dark matter, and how it acts as the scaffolding, or the glue, if you will, that binds galaxies together, because without it, galaxies would fly apart. And it keeps nerds like me and you and this team up at night because it's frustratingly invisible. It doesn't interact with electromagnetic radiation and its spectrum, and as such, every tool in our toolkit is basically useless. From X-rays to radio waves and light in between, dark matter does not interact with any of this. So, as so wonderfully explained by Robert Leah of Space.com, quote, that means scientists can only infer the presence of dark matter via its interaction with gravity, and the influence that interaction has on nearby ordinary matter and on light. End quote. Needless to say, that makes it a very difficult thing to study. And this has left one of the model's major predictions up in the air. Being that cold dark matter moves slowly relative to the speed of light, this should allow it to clump together to form structures. If so, those structures should be halos. Sometimes those halos grow heavy enough to anchor entire galaxies. Sometimes they don't grow large, and there's not enough scaffolding for things to take shape. In an email to Live Science, Gagandeep Anand dropped this massive discovery. Quote, these dark halos should be plentiful. However, most of them do not retain any hydrogen gas, thus remaining invisible. Cloud 9 lies at the very upper end of the dark halo mass range, thus allowing it to retain its gas, and therefore being visible enough through radio observations. This is indeed a strong confirmation of a cornerstone prediction of the lambda cold dark matter model. Cloud 9 offers the first hint of evidence that the universe could be teeming with low-mass dark matter halos that remained devoid of stars, as the theory predicts. End quote. Yeah, my friends, Cloud 9 is a spectacular failure. It falls short of having enough mass to collapse into a galaxy, but is massive enough, due to its dark matter component, to keep itself together, proving that a critical mass threshold exists, and so does the existence of halos. To help further prove this point, the team was able to do some rather long, very long other equations, and found that to keep Cloud 9's 1 million solar mass in its compact spherical shape, the dark matter scaffolding needed must weigh in at around 5 billion solar masses. That's a lot of something that we don't know what it is. So Cloud 9 is giving us an opportunity to really hone in and get more answers about what the universe is exactly. As to the chances of finding more relics like this, well, goddamn good luck. One, they are so pale they are easily outshined by other celestial bodies, and I get it. And two, as reported by Ivan Farkas of Live Science, these clouds are so ethereal and are likely to be eradicated by a process known as ram pressure stripping. Sorry, I'm an adult. Ram pressure stripping, which means, you guessed it, these delicate clouds get rammed as they move through space and their hydrogen gas gets stripped away. In an email from Alejandro Benitez Lambe to Ivan, he noted, quote, to survive as a dark, gas-rich cloud into present day, a system must meet two stringent and statistically rare criteria. First, its dark matter halo must have an atypically slow assembly history. If it grew too quickly in the early universe, the gas would have collapsed to form stars before the cosmic UV background radiation could heat it up. This energy keeps gas ionized, or electrically charged, and relatively hot, suppressing formation. Second, the system must remain sufficiently isolated. Fewer than 10% of such gas clouds may have remained as starlessly pristine as Cloud 9. End quote. So, the odds of finding another perfect failure may be low. Like really, really low. But honestly, that just makes Cloud 9 even more of a winner, in my book. And thank you for listening, rating, subscribing, following, telling your friends about this 5-way. Just text them that you have to say, I have to tell you about this 5-way. They will not answer you. But you can tell them in person when you meet them. And a bubbly thanks to the folks. Oh, and tell them about, before I thank Airwaves Media, tell them about failures. Talk about your failures together. Okay, now we can give a bubbly thanks to the folks over at Airwaves Media, the podcast network to which WTI belongs. If you love this show, and you do, you'll love the other podcasts in this family. And please, stay interesting.